So in today's lesson, we will focus our attention on solution sets of linear system. So basically, we will be talking about homogeneous system and non-homogeneous system. Okay, and then we'll look at the properties of these two kind of system. All right, a system of linear equation is said to be homogeneous if it can be written in the form, this is actually typo, it is AX equals 0, where A is an m by n matrix and 0 is the 0 vector in Rm. Okay, such a system which is AX equal to 0 always has at least one solution, and that solution is x equal to 0. So it is guaranteed that the homogeneous system will always have at least one solution, 0. Okay, the solution is 0, and this kind of solution is called trivial solution. Let me give you one simple example from your algebra. Okay, I want to take you to a high school or middle school or high school just for a few seconds, if you don't mind. Suppose you are given, it is just an analogy. Okay, I think it will help you to understand, to remember what it means. Suppose you are given x squared plus 2x equal to 0. Okay, since the right hand side is 0, and what we can do here is that we can take x common, so that means x plus 2 equal to 0. So it has 0 as one solution and negative 2 as another solution. So this solution is called trivial solution, and this is called non-trivial solution. Okay, trivial solution means the solution that contains 0. Just keep that in mind. Now we know that every homogeneous system has at least one trivial solution. But the question that we are more interested is whether the system has non-trivial solution or not. We'll talk about this in more detail. Let's look at one simple example. Okay, let us consider this system. So we have x1 plus 10x2 equal to 0 and 2x1 plus 20x2 equal to 0. So if you solve it, x1 plus 10x2 equal to 0 and 2x1 plus 20x2 equal to 0. I guarantee that x1 equal to 0 and x2 equal to 0 is one of the solutions. In another word, this x1, x2, which is 0 and 0, is one of the solutions. If you don't trust me, you can actually plug in this value and see whether the left side and right side are equal or not. For example, let me substitute this. If x1 equal to 0 plus x2 equal to 0, then 0 equal to 0, it's satisfied. And this also satisfies the second equation as well. Okay, you can substitute that value. So that means we are sure that 0 and 0, this is one vector, x, and this vector is actually one of the solution, which is, this solution we call trivial solution. Okay, now the question is, does this system has non-trivial solution? How do we check that? Well, I think the easiest method to solve this system is consider the augmented matrix. Okay, so consider augmented matrix and let us change it into echelon form. So augmented matrix is 1, 10, 0 and 220, 0. So what you can do is in R2 minus 2R1. So what do you get? 1, 10, 0, and this will be 0, 0, 0. So if you write the general solution, so this is your x1, this is your x2. So general solution will be x1 plus 10x2 equal to 0 and x2 free, right? x2 is free variable. So general solution, we must express that in terms of free variable. Basic variable is x1, so that's going to be negative 10x2. x2 is free variable. So once you notice that there is a free variable, that means the system has infinitely many solutions. One of the solution is 0, 0. We know that. That is a trivial solution. So it has how many non-trivial solutions? Can you tell me how many non-trivial solutions?
Infinitely many.
Exactly. Because x2 free means you can choose x2 equals to 1. Then in that case, your x1 equals to 10, negative 10. You can choose x2 equals to 10, for example, so that your x1 equals to negative 100. You can choose infinitely many because x2 is free. So these solutions are called non-trivial solution. Is there any questions between trivial and non-trivial? Now, I think you already know the process here, how to figure out whether the system has only trivial solution or it has non-trivial solution. All you need to do is consider the augmented matrix, change it into echelon form, and see whether it has any free variable or not. Let's look at this example. Okay, determine if the following homogeneous system, by the way, this is homogeneous because all the right hand side are 0, whether the system has a non-trivial solution. We already know that it has trivial solution. It is 100% sure. Every homogeneous system has trivial solution. Now, does it have non-trivial solution? If it has, then describe the solution set. Okay, let's try that. So for this, all you need to do is consider the augmented matrix. Which is 3, 5, negative 4, 0, negative 3, negative 2, 4, and 0, 6, 1, negative 8, and 0. Okay, I want you to change into echelon form. Okay, change into echelon form. I leave it to you. I trust that you will be able to do it, and let me know the echelon form. Okay. You guys already know how to change into echelon form. If you need help in changing the echelon form, check the previous class note or previous video from section 1.2. So the second row, when you change it into echelon form, you'll be getting 0, 3, 0, 0, and the last row will be all zeros. Okay. Thank you everyone who replied in chat box. Okay, I just copied your answer. I trust that you got the right answer here. Or if you want, you can write, instead of 3, you can write 1 if you like. Okay, you can write 1 if you want, because you can divide R2 by 3, and that's what you get. Now, let us write the general solution. Okay, so you notice that this has one free variable, right? So this system it is obvious that the system has one free variable. Okay, so if the system has free variable, then it must have non-trivial solution as well. So it has at least one non-trivial solution. It will definitely have trivial solution. That's not an issue, because we said at the beginning that every homogeneous system has trivial solution. So it has at least one non-trivial solution. Notice the language that I put. It has at least one. What it means is it can have one or two or infinitely many. So to be on the safe side, I just wrote at least one non-trivial solution. Now, in order to find that, so let us express this in general. Let us write down the general solutions for this system, okay? So general solution will be, you know that this is your x1, x2, x3, so you can write 3x1 plus 5x2 minus 4x3 equal to 0. And the second one will be x2 equal to 0 and x3 free. Now substitute the value there. So when you substitute the value here, you'll get 3x1 plus 5x2 is 0 equals 4x3, which means x1 equals 4 over 3 x3. Okay, so x1 is 4 over 3 x3 and x2 is 0 and x3 is free. So if I want to write this in nice form, what I can do is my x will be x1, x2, x3. So x1 is 4 over 3 x3, x2 is 0, and x3 is, well, let me write x3 here as it is. So that means if you put the x3 there, you're going to get 4 over 3, 0, and 1. So any question? Let me represent this as V. Okay, this is my vector V. So I can write x equals x3V. Okay, and this is the general solution, and this form is called parametric vector form. Okay, in general, when you have the system, when you have this form, then generally what we do is, or we can write x equals tv. x3, I want to replace that by t. That's what we do in general. Our parameter is t. So this system, this solution of the system is called vector parametric form. Okay, if you write the solution in this form, it is called vector parametric form, where t is our parameter. It's just a variable, okay, random variable, parameter. So the variable sometimes called parameter. All right, that's it. Now if you want to look at for the trivial solution, let us just, so we are done kind of, but let us observe what is going on here. Suppose if I want to find trivial solution, okay, if I want to find trivial solution, what should I do? What is the value of x3? For trivial solution, x3 equal to 0, right? If I suppose x3 equal to 0, then guess what? So x3 is 0, 0 times 4 over 3, 0 and 1 will be 0, 0, 0. So that is our trivial solution. But for every choice, every other choice for x3, you will get non-trivial solution. It means this system has infinitely many non-trivial solutions. Okay, lots of things we discuss here. We talk about homogeneous. We talk about general solution. I think we already know what is general solutions because we did that before. And we express the solution in vector parametric form. Okay, any questions so far? For every other value of x3, we get non-trivial solution. Okay, we know that. Let us look at this graphically. Sometimes it's fun when we have all of these algebra going on, and if we can visualize this clearly, and that makes more sense sometimes. Okay, so let us see what is going on here. So this vector has 3 component, means this vector actually is in R3. So we have x1, x2, x3. All right. If I suppose x3 equal to 0, then it's all 0. That is the point when x3 equal to 0. Suppose I want to suppose x3 equals to 1. Okay, for x3 equal to 0, so your x equal to 0, 0, 0. We know that. For x3 equal to 1, for example, your x will be 4 over 3, 0, and 1. Let me draw that point. Let me just plot that point. So x1 is 4 over 3. Let's say this is 1, this is 2, 1, 2, this is 1, 2. So your x1 is 4 over 3 is somewhere here, and x2 is 0. Okay, it will go nowhere. And x3 is 1, so 1 is right there. So this is the point. Okay, this is the point. The point is 4 over 3, 0, and 1. All right, this is our point. Now, if I join these 2 points, well, let's say your x3 is 2, for example. Then your x value will be 8 over 3, 0, and 2. Can you plot that point somewhere? It will be somewhere there. And if you suppose x3 equals to 3, then your x value, you can calculate that point will be somewhere there. So if I join all of these points, guess what? I will get a straight line, right? It's a straight line. So the homogeneous system of equation, if the solution is in this form, TV form, then what we get is that we just get a straight line. All right, so that's the thing. Just keep that in mind. Now, let's move forward. Okay, well, I thought I'll give you another question here. I think anyway, so let's try one non-homogeneous system. Okay, let us consider non-homogeneous system. Non-homogeneous system. Okay, let's look at one example. So for this, I just want to copy the same questions as in example 1 on the left hand side. Let's say 3x1 plus 5x2 minus 4x3 equals, it was 0 there, but I'll change with some number, okay, later. So the second one is negative 3x1 minus 2x2 plus 4x3 equals something, and let's say this is 6x1. I'm just copying the left hand side exactly the same as we have. Did I copy the right thing? Let me see. Yeah, I think so. Is this plus? Yeah. Okay, then right inside all 0 earlier for homogeneous equation. Here, some of them are non-zero. Let's say this is 7, this is -1, let's say this is -4, okay? Now this is a non-homogeneous system. And I want you to find the solution set in vector parametric form for this system. Okay, so for which what you need to do is, well, this example 2 is basically the same thing, right? We just express that system in terms of matrix form. So consider the augmented matrix. So the same questions can be given in this way or in this way. It's the same thing. Now consider for this one, consider augmented matrix. Which is 3, -3, 3, 5, -4, 7, -3, -2, 4, -1, 6, 1, -8, and -4. Okay. Now change it into echelon form. I leave it to you guys. Change to echelon form. So the echelon form will, you already did it before. On the left hand side, I just copy what you did earlier. It's the same thing. So I believe what you found is 3, 5, -4, 7, and this is 0, 1, 0, and I don't know what is that. This one, and then the last one is all 0, and I just want your help to figure out this one and this one, these two numbers. Okay, let me know. So you mean this is 3 and this is 6, right? That's what you get. So basically what we can say is that you can divide both sides by 3, I mean the R2 by 3, so that you can write this as 1 and 2. Okay, so that's what we get. Okay, so now let's try. So general solution is 3x1. You know that this is your x1, this is x2, x3, and that is the constant. So what we got here is 3x1 plus 5x2 minus 4x3 equals 7, and x2 equals 2, and x3 3. Now let us solve this for x3. So that's going to give me 3x1 plus 5x2 is 2 minus 4x3 equals 7. And if you simplify that, what do you get? So here I just need 3x1 this side, so that's going to give me 7 minus 10. 7 minus 10. Okay, 7 minus 10 is -3, and plus 4x3. So x1 equals -1 plus 4 divided by 3x3. Okay, we got that. So our solution is, x equals x1, x2, x3. Remember guys, this one is a vector because it's one column matrix is called a vector. Even though I don't write that vector sign, then understand that I'm talking about vector here. Equals x1 is what is x1? -1 plus 4 I can write this as, yeah, -1 plus 4 over 3 x3, and this guy is x2 is actually 2, and x3 is free, x3. So you can write this as -1 plus 4 over 3 x3. You can write this as 2 plus 0 x3, and this one is 0 plus x3, right? We can write that way. So in this, if you split them, you're going to get -1 to 0 plus x3, and you'll get 4 over 3, 0 and 1. Notice that this part is the same as before. Let us suppose that this is my V, and let us suppose that this is my P. Okay, so then X is in the form of P plus X3V. Or to be more general, remember for our parameter, here our variable or parameter is X3, but in standard form, we use T as our parameter. So we can write X equals P plus TV. Now let us compare the solution in the previous case and now. So previous case for homogeneous, solution was X equals TV form. And for non-homogeneous, okay, let us just see. For non-homogeneous, what we got is X equals P plus TV. That's what we got. P is a vector, which is -2, -1, 2, 0. Okay. And now, what does it mean? Suppose, let me take you to high school just for a few seconds, if you don't mind. Suppose you have, let's say, y equals x squared. And if you draw the graph, then the graph would be like this, right? Everybody know that. It is your y equals x squared. It's a parabola. Suppose if I do y equals 2 plus x squared, then what? Let me use a different color. Y equals 2 plus x squared. So I'm using the blue color. So my graph will move to 2 step up, right? So this is 2. So it shifted 2 up. So this means shift the graph by 2 units up, right? That's what it is. Now compare this. Earlier we have a line. Okay, let's say this is a line, whatever line that is. Let's say this is our x equals TV. The figure is not drawn to scale. Okay, and then if I write x plus p, x equals p plus TV, then what it means is I shift this by p unit. Okay, this vector p is this one. I just shift that by p unit so that this will be p plus TV. Same thing like here. Okay, so in case of non-homogeneous system, then the graph will shift by the vector p. So that's the geometrical meaning. So one thing very important, when you have a solution x equals TV in that form, then this line, this is a line, this is equation of a line which passes through this one, because x equals TV means I can write 0 plus TV. So that means it passes through origin. Now when you have this p plus TV, x equals p plus TV, then it's the same line, but it passes through p. Okay, it just shift by P in another one, or you can say shift by P unit. So that's the geometrical meaning. All right, now let's try one more. Okay, some of you asked me to explain what is the graphical representation of P plus TB again. So let me give you one example. So when I say, let's say this one is my TV. So here is a vector V, okay, and TV means it's just a straight line. It goes forever. So if B is 1, then this is the point, this is the vector. If B is 2, then this, just the double. If V multiplied by, if T is 3, then this will be 3 times. If T is -1, it will go this direction. So you will get TV is a line passing through the origin. TV means 0 plus TV, you can write that way. So it passes through the origin. Now, when I say P plus TV, let's say P is a vector. Let us suppose that vector P is here. Let me use a different color. Vector P is, let's say, this one. Okay, this is my P vector. Then when I say P plus TV, so it means the vector passes through P and parallel to TV. P plus TV means the vector, the meaning is vector passes through P and parallel to TV. That's the meaning. Now, passes through P and parallel to TV is this line. Let me just erase that. This is your P plus TV. So what is happening? Well, it just shifted by P vector. Okay, so here, no matter what position you consider, then this is just shifted by P. All the points are shifted by P. It just like as I show you one example, when we have y equal to x square, it's simply a parabola. When we write y equals 2 plus x square, every point will shift 2 unit, right? Every point will shift to it. The same thing here. So it just shifted by the vector P. That's it. Make sense? Okay, there is one question. Can you explain P plus TV graph? Is TV a line or a plane? It's a line. Clearly, it's a line. Because V is a vector and TV is just a line. Because if V is a vector, then if T is 1, simply it is V. If T is 2, then this will be 2V. That means this is your V and this is another V. So this is the point 2V. Okay, and 3V, 4V. Negative V this side, negative 2V this side. So it is a line. P plus TV is a line passing through P parallel to TV. Okay. All right. Now let's look at example practice problem 2. Write the general solution of 10x1 minus 3x2 minus 2x3 equal to 7 in parametric vector form. Okay, we want to write this in parametric vector form. Okay, let's try this second problem and we'll go back to problem 1 later. So let us write, to write the general solution, what we need to do is consider, I think you guys can do it by yourself. Consider the augmented matrix. Which is 10, -3, -2, and 7. Okay, change it into echelon form. Well, it is already in echelon form, right? It's just a one row, already in echelon form. So this is your pivot. Therefore, this is your x1. X1 is basic variable, but x2 and x3 are free variable, right? So here the general solution is ten x1 minus 3x2 minus 2x3 equals 7, x2 and x3 free. Okay, earlier we had only one free variable. Now we have two free variables. So what happens if we have two variables? Let's look at that. Let's solve this for x1. So I'm going to get 10x1 equals 7 plus 3x2 plus 2x3. So I can write x1 equals 0.7 plus 3 over 10. I can write 0.3, 0.3x2 plus 0.2x3, right? So you can write that way. That is our general solution. Now the form here is that it is in the form of, this is a constant. I can write this as P, and this one is, let's say, T x2, but we can write, let's say, V, or maybe, yeah, U, let's say, plus this one is maybe T1, T2, or maybe, I don't know, x2, and let's say x2 and V, U, plus this is x3 and V. Let us represent that way, where U is a vector, where U is, where U equals, it is a vector 0.3, and V is a vector which is 0.2. As a matter of fact, they are just a, line on the axis. Anyway, so now in this case, what we got is, when we have two variables, this is the equation of a plane. Equation of plane. Okay. Now, when we have P here, when we have two variable, two free variable, so this gives us equation of a plane. When we have one variable, one free variable, line. Okay, please remember this. One free variable gives us a line. Two free variable gives us a plane. Now, this is a plane, and this P is just shifted by P unit here. So that means this plane is, this is a plane passing through the point, P and parallel to the plane x2u plus x3v. Okay, now if you want to look at this graphically, suppose you have a plane here. Let's say the plane is let's say this is my plane. Okay, let's say this is the plane represented by this x2u plus x3v. This is the equation of this plane, let's say. Now, when I shift this plane by P unit as a P vector, so P vector is, let's say this is my vector P. Okay, this is vector P right there. Now, what happens is that the plane is passing through this point P and parallel to this plane. So that means the plane will be this one. Okay, this plane is parallel to this and passing through P. So it means it's shifted by P unit. All right, guys. Now, any questions so far? So another example would be this. Let's say the equation of this plane is x2u plus x3v, and then it's shifted by P unit. So P is somewhere here, and so this one will be P plus x2u plus x3v. It just shifted by P units. That's it. So practice problem number 1. Each of the following equation determines a plane in R3. Do the two planes intersect? So what does that mean? Does the system have a solution? If so, describe their intersection. Let me copy that question. I need more space here. So sometimes you see these planes are parallel, so they do not intersect in this example. But here in this example, planes sometimes intersect. If they intersect, then they always intersect in a line. Okay, so the question is, we first need to figure out whether they intersect or not. And if they intersect, what is the equation of the line where they intersect? Okay, that's two things we need to do here. Let me just copy the equation. So here, practice problem 1. Equation is x1 plus 4x2 minus 5x3 equals 0. And next one is 2x1 minus x2 plus 8x3 equals 9. Did I copy the right question? x1 plus 4x2 minus 5x3 equal to 0, 2x1 minus x2 plus 8x3 equal to 9. Okay. Now, so for this, whether they intersect or not, whether the system is consistent or not. Okay, so for this, what we do is consider the augmented matrix again. Which is 1, 4, minus 5, 0, 2, minus 1, 8, 9. Change it into echelon form. I trust that you guys know how to change it into echelon form. And let me know what is the echelon form. I'll wait for your answer. Okay, thank you. Thank you guys, you got it. You got the echelon form according to which this is 0, this is 1, this is -2, and this is -1. Okay, now let us write the general solution, okay? General. So we notice that this
Sorry,
is...
it should be 0, 1, -2, +1.
Okay. So yeah, so I think it is negative because, you know, many of you got negative. So more people got negative. So I trust that this is the negative one. So notice that this is a consistent system, right? The system is consistent. Therefore, the system is consistent. So there is a solution. There is a solution. Now we want to find the general solution here. Okay, let us find general solution. So that's going to give me x1 plus 4x2 minus 5x3 equal to 0. And another one is x2 minus 2x3 equal to 0 and x3 free. So this from here we'll get x2 equals 2x3, and from there we'll have x1 plus 4, x2 means 2x3 minus 5x3 equal to 0. So this is gonna give me x1 equals 4 minus 3. Oh, did I do something wrong here? So this one is 1, I believe, -1. Sorry guys, this one is -1. And so you'll have here -1 plus 2x3. So this one will be 4 times -1 plus 2x3. And if you simplify, let me know what you get. It will be, I believe it will be x1 equals 4 minus 3x3. Okay. So the solution here is x equals x1, x2, x3 equals x1 is 4 minus 3x3, x2 is -1 plus 2x3, and x3 free. So x3 is x3 simply. Or you can write 0 plus x3 if you like. So I can write this as 4, -1 and 0 plus x3, and another vector here will be -3, 2, and 1. Okay, so now we know that, let's say this is our u plus this is our v. Maybe this one is, let's say, p. Okay, this is v. Now we notice that we proved that the system is consistent. That means the system has a solution. That means the plane intersect. Therefore, the plane intersect. And can you tell me, this one is in the form p plus x3v. Is this a line or a plane?
It's a line.
It's a line passing through P and parallel to x3v, or parallel to V, you can say. Okay, it is a line passing through P parallel to the vector V. So therefore, the plane intersect at the line x equals P plus x3v. Okay, that's it. So if you have any question, let me know. Otherwise, we are done with this section.